In the previous episode, I joined these two wooden panels using a dovetail joint. Then I invented a system that automatically launches the ball onto the playfield using Arduino and a MOSFET driver, and it works perfectly. I built the ball launcher myself, starting from a piece of plastic tubes and steel rods, then turned and finished it with 2 springs. It shoots hard and is very sensitive. Then I filled the table with all the colored plastics, which will light up with LEDs. Using my 3D printer, I also made the supports for positioning the rails, arranged across half of the playfield. And there it is. The first half of the table completed. It's already playable as it is. So, what are we going to see today? Something really powerful and spectacular. So sit back and enjoy this 6th episode. Let's start with the dual-function automation system, ball management and the anti-return mechanism. In its current version, the mechanism works beautifully. The ball arrives, the sensor detects it, and it's fired along the lane, ready to be put back into play. Then I revisited the project with a small modification. I designed a new mechanism using a lever system. When the ball passes, a small arm activates a counting microswitch and at the same time prevents the following ball from moving forward. This way, any intruder ball is sent back to the launcher, while the main one passes and is counted correctly. Now the system works perfectly, guaranteeing error-free ball counting. Let's see it in action. I had to rebuild a completely new playfield because in part 2 of the Pinball Machine, too many things had been changed, so I made a brand new one from scratch, fully redesigned. Even the colored lights were improved, this time with a slightly thicker diffuser. And, as I've always taught you, always make test pieces with different tolerances. That's how you find the perfect offset to get a fit down to the 1,000th of a millimeter. You do it once and it will help you forever, especially if you work with a 3D printer and a laser engraver together. It also helps improve light diffusion performance. I even created a triangular model dedicated to the multi-ball mode, a really cool feature, but we'll see that later on. Now I need to reassemble everything, but there's one part I wanted to revisit, the launch lane. When the ball was being released into play, there was an empty space. I didn't really like it. So, since the launch lane is such a key part of the design, I created a system that's not only aesthetically nice, but also functional. Because this isn't a pinball machine made just to make a pinball machine, here everything has to feel alive, even the ball launch system. I made it in 2 colors, and those holes you see are not random. Later, I'll create a PCB with 10 LEDs that will display a chasing light effect every time the ball is in the launch area, ready to go. The chrome rail is fixed with a high-bond double-sided adhesive using a special glue, so it will never come off. I have to say, I really love how this combination looks. Now that the chrome rail is in place, I secured the piece with a side screw and a beautiful polished washer. And for those who missed the last episode, here's a kind of cannon that shoots the lost ball back into play, a bonus feature you can unlock during the game. Unfortunately, these solenoids have a limited stroke of only 10 mm, so I couldn't design a system that fired the ball immediately when detected by the sensor. If it arrived too fast, the solenoid would lag behind. So here's my clever idea. I moved the sensor slightly higher, so when the lost ball passes through it, the system has time to activate the cannon. Not to fire it right away, but to hold it first. After a set amount of time, once the ball has lost its speed, the cannon relaunches it using a precisely timed detach and engage sequence. This way the ball returns to play smoothly without any problems. At first, I considered using a lever system with an infrared sensor, but later I switched to proximity sensors, which are much more reliable and eliminate any mechanical wear. Let's continue assembling all the elements that make up the second half of the playfield. Nothing complicated here. It's just about completing the paths with chrome rails, rebound rods of various shapes and sizes, and the plastics that define each area. On the new playfield, I made 1 mm holes so I can screw the M3 bolts directly without having to use nuts underneath. Much more practical and faster. Meanwhile, I'm working on the 5 target zone, where I carved out a small quick access passage in this plastic section by inserting guides. Every bit of space has to be used efficiently. Once all the pieces are assembled, the plastic is secured with screws. Here's the little passage I created. And this one is another special hole, but we'll get to that soon. Now let's install this super long bidirectional rail, with its supports glued in place. This is the path that leads to the black hole. And yes, I mean the space one. I had to design a custom path not only to hold another rail from a different path, but also to guide the ball perfectly to the center of the hole. Next, we move on to completing the areas with the chrome bumpers, which look fantastic. This passage is crucial because it allows the ball to make a full loop, and depending on its speed, it can create different dynamics. On the other side, if the time gate is open, the ball can descend to the lower playfield. I'm now closing off this section, and the secret passage as well. From this point, the ball has to reach here and through a solenoid-driven mechanism be launched back into play via the space chimneys. Here's the system I designed, modeled in Fusion 360 and then 3D printed. I created two different models, both serving the same purpose, to catapult the ball up to the upper playfield through another solenoid, slightly more powerful than the previous one. It's a 12-volt model, but before finalizing it, I'll make a small change. I'll remove the small blind nut and replace it with these special anodized aluminum knobs to provide a larger contact surface. Then I'll add an IR sensor to detect the ball and trigger the solenoid to shoot it back into play. I also printed the second model, the one that receives the ball from underneath the playfield, and here they are finished. Believe it or not, I designed and built them in just one day. They look great in PLA, but in resin, it's a completely different story. Let's install them and give them a test. I'll use this clear polyethylene rod to perfectly align the hole and find the optimal orientation according to the design, avoiding any collisions with other parts. Then I'll secure it with threaded screws. The other mechanism, however, required a special blue pathway. I made it as a test, but I actually like it, so I'm keeping it that way. It's a pity it won't be visible since it's only used to let the ball pass underneath the playfield. At the end of the blue path, the launch cannon sits perfectly flush. I fixed it with 2 screws and nuts, making it even more stable. Then I moved on to installing the blue bridge. Yeah, I might have gone a bit overboard with the screws. Here they are, the 2 cannonballs, fully completed. Let's test them out. The first one works, and the second one too. Perfect. But how exactly does the ball return to play? Well, we also need the space chimneys, because without this deflection system, the ball could easily smash the glass. Here they are, the space chimneys. What are they? They're elements that redirect the trajectory of the ball, guiding it downward through a parabolic curve. This version won't actually be mounted on my pinball machine. It was just a prototype. I completely redesigned it with a different geometry. Besides making it black, I also added a 0.9mm groove, because I came up with a brilliant idea. Piece and attached it to the chimney using high-strength double-sided tape. I like the idea of having 2 thin reflective lines contrasting with the aluminum, and honestly, the result looks amazing. And here they are. Look how beautiful they are with their white supports. I positioned the first one. It directs the ball into the secret passage. If it's not activated during gameplay, the ball continues along its normal path. But if the secret passage is active, a special solenoid diverts the ball toward the cannonball launcher, which fires it into a suspended rail. Now let's move to the second cannon. When the ball comes from the passage under the playfield, it reaches the other cannonball, which launches it onto another elevated track, and this one works perfectly as well. Finally, I can close off the upper left area where the third flipper will be installed. Look at this stunning new game zone. I've always loved this part, and I'm sure you've seen something similar in arcade pinball machines. Using 2 locked balls to score extra points, I like to call it elastic impact. It's the classic transfer of motion, just like in Newton's cradle. The first ball hits the second, transferring all its momentum and elastic energy to the next one, while appearing to stay still. This is the multiplier zone, featuring 3 lanes with their corresponding lights. When all 3 are completed, the score multiplier increases to 2 times and eventually up to 5 times, displayed by 5 LEDs. The lanes are built using yellow rods with black O-rings, giving the ball an excellent rebound. Then I add aluminum caps on top of the rods, once they're cut and drilled with my CNC, and I bend 2 thin metal strips that also act as side rails for the balls. Before mounting them on the playfield, I made a laser-cut test jig to individually check every section of the pinball machine. But just look at this color combo. Yellow rods, black rubber, aluminum caps and violet washers. Such a satisfying match. Let's see how this system looks once assembled. Even the measurements turned out absolutely perfect. Okay, but what does it look like at night? Here it is. These lights were made on my CNC, composed of 2 pieces to adjust their height. They run on 12 volts and fit perfectly into their dedicated holes, with only the head showing on the other side. On the left you can see the first prototype, and on the right the final version. There will be a whole lot of these static lights throughout my pinball machine. After several tests with the old IR sensors, the system proved to be well designed. The only change I made was replacing them, as you've seen, with proximity sensors, which are much more stable and detect only the ball without interference. They're extremely responsive and sensitive, capable of detecting the ball even at very high speeds. Finally, everything is ready for installation on the new playfield. This section instead is the multi-ball module, characterized by its 2 colors, red and blue. It also has another function, guiding the ball into the 4th flipper area. I have to say, even though the artwork, casing, ramps, rails, suspended bridges, decorations and targets are still missing, I really like how it's turning out. I'm very proud of these months of intense work, even if it probably cost me a few years of my life. And speaking of targets, let's see how I made them. It all starts here. Remember the cable ties I bought on Temu? Well, those are exactly what I used to make the targets, with perfect size and elasticity. I built some PLA jigs combined with aluminum profiles to drill holes that are almost at the limit of what's possible. In this slot, I can fit 3 cable ties at once, which really speeds up the process. I left one side of the slot open so I can check if all the ties are properly aligned. Once everything's in position, I tighten them up and drill with a 3mm bit. This setup allows me to drill through ultra-thin material while keeping every hole perfectly centered, and it drastically reduces production time. Sure, it took me about an hour to build this system, but you just can't get this kind of precision any other way. And as you can see, in a single pass I made 3, all perfectly identical. It also helps me mark exactly where each cut will go. Here they are, all done in under 10 minutes and every single one is identical. Now they just need to be cut to size, and for that I'll use a pair of pliers. Let's see if it's really that precise. Absolutely perfect. I also 3D print the insulating spacers in PLA, white and grey, using a high precision interlocking system. What's missing is plate B, the one that needs to be isolated and paired, so I switch to a different jig. Then I drill with a 5mm bit, which makes the process even trickier. Never try drilling by hand without a tapping or guide system like this one on such thin materials. The bit would tear right through it, and it's really dangerous. Absolutely perfect. Guys, always work with method and precision. That's how you stay safe. The result came out beautifully. Once all the holes are done and the plates are cut to size, I move on to assembling the targets. I printed the bases for all the models, from the largest one down to the single target, along with their round tops. As you can see, I also added small fins to hold them in position. Of course, I printed them in different colors. As you can see, I also added small fins to hold them in position. Now, starting from 2 aluminum bars, I use my CNC to mill the rigid strikers, which prevent the targets from bending when hit by the ball. Here they are, all ready to go. They just need a bit of post-processing to remove the marks and adhesive tape, but the final result is perfect. To lock the plates in place, I use rivets, but I don't need the steel shaft. I remove it because I only need the hollow head. I insert it into the hole, then add the plate. No pliers needed, just a vise. The key is to make sure the flattened part sits perfectly flush. Next, I insert the spacers. Only one of the plates must be isolated from the screws, otherwise it would short out. On the rigid striker, I mount small O-rings secured with screws. These act as shock absorbers. The contact section is now complete. I just slide it into its holder. See, even with a strong impact, the plate won't bend thanks to the rigid aluminum reinforcement behind it. Of course, you can also make them in PLA or ABS. They're more flexible but still work great. Since the system passed all the tests, it's time to make the rest. After testing one, I built the larger version with 5 targets using the same technique. Once the first one was finished, I moved on to the remaining 4. There's another important detail. The connections to Arduino aren't wired directly to the plates. They're soldered to a connector mounted on a small board. Even the original pinball machines don't have this feature. The board is positioned right behind the target contacts. This is a special soldering primer for steel. That's how I managed to solder the plates. It's a unique alloy that allows solder to adhere normally to steel surfaces. After completing all the solder joints and bridges, here's the finished product. Now let's see how it works. I wrote a small Arduino test sketch to check the plate contact response. Each target triggers its corresponding light on the playfield. Just like in a real pinball machine. Well guys, I'm really happy to see everything working perfectly. Let me show you all the others I've already completed. There are quite a few of them. Isn't it amazing building stuff like this, and the satisfaction of seeing it all come together? Priceless. Of course, behind all this there's a huge amount of design work. I could easily have dedicated an entire episode just to these targets, considering all the design, testing and 3D modeling time. But I decided to condense it all into a few minutes. And here they are, all targets installed and perfectly synchronized. Let's do a quick manual test to see the effect, and I must say everything works flawlessly. In the next episode, we'll see the pinball machine finally completed, at least the main playfield section, with ramps and rails made using a very special technique and a DIY RGB display that creates a programmable space-themed background. We'll also see how the left and right kickers, the coils and the digital tilt sensor are all activated. And finally, I'll show you the finished playfield artwork, which I just completed these past few days. Basically, you'll be witnessing the final chapter of my pinball machine's playfield. Only the exterior shell and wiring are left to finish.